Hey everybody, this is Mr. McKee with Net226. Today I'm going to go over Packet Tracer 2.2.13, which is point-to-point single area OSPF version 2. Alright, I do have my workspace on the right screen, and if you can take a look, I've got 3 local area networks. Just notice the differences are just the third octet. LAN 1 is 10.0, LAN 2 is 20.0, and LAN 3 is 30.0. Alright, from there you got a layer 3 switch connected between the PCs on every LAN to a router. Alright, LAN 1 corresponds to router 1, 2 to 2, and 3 to 3. And then you have 3 routers connecting all of those together with multiple routes between the LANs. Alright, the networks for the router-to-router connections are /30, which makes sense because you have 2 interfaces, a network and a broadcast address, so 4 possible addresses per network. That doesn't waste any. Alright, and then they started out with 10.1.1.0 network, so your interfaces will be a .1 and .2, your broadcast will be .3, and then it goes over to the next network, .4, and then on that network, .5.6 will be the usable host addresses for the interfaces, and then .7 for the broadcast, and then finally .8 for the network down here from router 2 to router 3. So the interface will be .9 and .10, and broadcast will be .11. Alright, and we're going to need to know that, and we're going to have to go ahead and I'm going to use a Excel spreadsheet to show you guys how to kind of like figure those out, figure out the actual subnets from the CIDRs, and then convert your subnet mask to a wildcard masks. All right, because we'll have to do that. It's best to like write that down versus try to do it in your head, unless you have to, just because you make some mistakes. It's not good. All right, so addressing table. Each router has 2 serial interfaces and 1 gigabit interface. All right, so those are there. Pretty much everything's lined up pretty nicely, so there's no real issues. Let's see. Okay, yeah. All right, and all PCs have IP addresses which correspond to their local area network, /24s. All right, so let's go ahead and get started. So what we're going to do is we're going to configure router IDs, we're going to configure networks for OSPF routing, configure passive interfaces, and verify OSPF configuration. In this activity, you will activate OSPF routing using network statements and wildcard masks, configuring OSPF routing on interfaces, and by using network statement quad 0 masks. In addition, you will configure explicit router IDs and passive interfaces. All right. And it does give you a lot of the commands in here, so it should be all right. So first thing we're going to do is part 1, configure router IDs. All right, start OSPF routing process on all 3 routers. Use process ID 10. So we're going to be typing in a router OSPF, then process ID 10 for all the routers. Because best practice, it tells you that in, I think, module 1 to use the same process ID for all routers in an area. All right, so let's start with router 1. And probably the best thing to do would be to start up your OSPF process and then also type in your router ID for each router at the same time. So let's go to enable, configure key. All right, so it tells us to do router OSPF, process ID is 10. All right, and then router ID. All right, so if we didn't enter this, it's going to go by the IP address of the router, but we're going to explicitly enter this so it knows which has priority as the DR and the BDR. All right, so 1.1.1.1. All right, and notice the completion rate went up a little bit, so That is promising. All right, router 2. And also I like to check, just as a habit, always check the version of the software. You know, I can tell that this does crypto because it has a K9 on it. ISR 4300 series. So it's a fairly new router. All right, log messages. All right, let's go to global config. All right, router OSPF. All right, make sure we're using the same process ID of 10 for all 3 routers. All right, then router ID is going to be 2.2.2.2. All right, and finally, let's do router 3. PF10, and then router ID is going to be 3.3.3.3. All right, so we're good. We're good there. All right, now for part 2, that they have you answer a good bit of questions, so we'll go through those. But I'm going to give you guys a Word document. I'll attach it to the Moodle submission link, so you guys can answer those questions as part of the homework. All right. All right, so the first question is, how many statements are required to configure OSPF to route all the networks attached to router R1? So right here, we're going to need enter a command for each of these 2 WAN links, which are serial links, and then this one a LAN connection. So it'll be 3 total. Let's see. Next question is, the LAN attached to router 1 has a \24 mask. What is the equivalent of this mask in dotted decimal representation? All right, so I like doing this in Excel, and really when I do the CCNA exam, now I haven't done the new version 7, I did the version 6, but one of the first things I'll write down on the little dry erase board that you get when you go into the exam, if you do your \24 through 32s, and on here, if you notice, I can type in \24, say in the cell A1, let's do A2, \24. It knows if I drag over here, it'll do it all the way up to \32. All right, so write that down. And now this is referring to the 4th octet, because all the other octets are going to be 255.255.255.0. All right, so 24 is going to be .0, 25 is going to be 128, 26 is 192, 27 is 224, 240, 248, 252, 254, and 255. All right, now I know a lot of you guys, this is good to go over it. I go over it every time I have any of the networking classes because it's easy to forget. But what that's saying though, all right, if you have a \24, that means the first 3 octets, which are all 255s, that's the network address, and then the 0 you can use up to all of the addresses in that 4th octet for host addresses. All right, if that works for you, that's great. You don't want to waste any. Now, if you do a \25, that's going to make it a 255.255.255.128. So you'll make 2 subnets. Each of them have 128 possible addresses, but now you're going to start losing addresses when you do that, because you're going to have, instead of one on \24, instead of one big class C subnet of 256 addresses, with one network address, which is .0, and one broadcast, which is .255. You're gonna when you go to 225, you're breaking that up into two 128 address networks. So you have two network addresses and two broadcast addresses, and that's going to keep doing that. When you keep ordering bits all the way up to 32. All right, so just understand that. But I always like to write this down, and then what you're looking at when you look at the 0, just think of that as being 256. All right, 256 possible addresses, and then you go down to 25. So 256, half of that is 128. All right, and then when you go to 26, you're doing 128 plus half of it. So 128 plus 64 is 182, and then from there, half of that is 64. So 64 plus 128 is 192. Half of that is 32. So 192 plus 32 is 224, and then so on. All right. And we'll show you with subnet wildcard masks. It's the opposite, or I guess you'd say the inverse of the subnet is the wildcard mask. All right, because 32 would be, and I'll do this in all 4 subnets. Let me do this. Let me insert something right there. This is CIDR. This is subnet, and then wildcard. Now I'll start over here because this makes the most sense. All right, so the opposite of that is 0. All right. The opposite of this would be all right. So this is kind of like tricky at first, but basically the wildcard mask is going to be take 255 and subtract the subnet mask from that, and that equals to the wildcard. So equals 255 minus subnet. All right, so hopefully that makes sense. So right here, \31, that's 255 minus 254 is .1. All right, 255 minus 252 is 3. All right, this is 7. All right, 255 minus 40 is 15. All right. Let me make sure I don't add up wrong. 3163. All right, 127. And then 255. All right, so basically this is, and really Cisco routers and things like that are the only place I've seen this used, but basically what that's telling you, that's how many bits are left. So you kind of like inverse it. So whatever number's left when you do a wildcard mask is the numbers you can still use. So the last thing I was told, hearing from, I'm pretty old myself, but people that are maybe 20 years older than me, before they had subnet masks, everything was written as a wildcard mask. So basically, it would just show you how many bits you had left over to use. So instead of 255.255.255.0, you would have a 0.0.0.255. So that tells you all the zeros, you can't use those. All you can use is the last 255. Or actually, and you have 0 as your first number, so 256 addresses are usable. All right. The reason for that was because since that's a lower number, you had less overhead. You know, obviously the numerical value is lower. when you do a wildcard mask, so that helps out, you know, with overhead. I haven't really researched that, but that's what I was told by one of the Cisco guys. All right, so now we've done the wildcard configuration, or the wildcard equals 255 minus subnet. So what this will look like though, it'll look like this. It's not going to look like 255.255.255.0. It's going to be 0.0.0.0.0. All right, so you can't use that right there. Means you can only use that address. You can't use any other addresses. All right, so this one would be 0.0.0.0.1. All right, this one 0.0.0.3, 7, and so on. All right, I'm gonna pause this. I'll enter all the rest of them so we can look. All right, so I filled in all the leading zeros. All right, so it's kind of weird to look at that for the first time, but if you look at a \32, that would mean you only can use the IP address that you've received. All right, so if you're 192.168.0.1, you can only use that address. All right, that's \32. So if you look at it as a wildcard mask, instead of 250, it would be 255.255.255.255. All right, and that would mean you have a \32 or cider 32. A wildcard mask though is the inverse of that. So take 255 and subtract that from the subnet. That'll give you a wildcard mask. All right. So don't think of that as one bit left over, 3 bits left over, and etc. Just think of it like this. All right. \30 is usually a router-to-router connection. All right. So you don't waste any IP addresses. You got a network address, a broadcast address, and 2 usable host addresses. All right. So looking at this, if you count up in binary, your first number is 0. All right. So 0 plus 3, you actually have 4 addresses possible. All right. So you put it like that. You put the wildcard mask in, you can figure that out. All right. So a .7 wildcard mask would be 7 plus 0 would be 8, and so on. All right. Doing it like that makes a lot more sense. All right. So hopefully that makes a little bit more sense. All right, but that's just the way they enter the wildcards for Cisco devices. So just get used to recognizing it. All right. So if you have 255, you do the reverse. Any other numbers, you take 255, subtract it from that subnet address, and you'll get whatever you're left with is what you put in for the wildcard mask. But if you sit down and think about it, though, it does kind of make sense because it shows you what you have left to use, not really what you have total. So if you look at 255.255.255.255 for like a \32, you would think you can use all of those addresses. But in actuality, 255 is your network portion, so you can't use those. So I don't know which one's more confusing, but you need to understand how each of them are set up. Now, when I said I write down my CIDRs and my subnets, I don't really write down the wildcards because, especially if I was like in a stressful situation, I might mess those up, or they might, at first glance, they look like they're not correct, maybe, because if you don't, think about it. So I don't write those down. But yeah, first thing I do when I sit down, get a little dry erase board, I write down my CIDRs and my subnets, and I just have those memorized. All right, but wildcard mask equals 255 minus your subnet, and whatever you're left over with is what you put down for your wildcard. All right, and we're just going to assume that we're going to have a class C address. All right, so that answers that. All right, so the LAN attached to the router 1 is a \24 address, or \24 mask. What is the equivalent of this mask in dotted decimal representation? So dotted decimal is all the octets separated by dots. So that looks about right. All right. Subtract the dotted decimal subnet mask from 255.255.255.255. What is the result? So just 255 minus, in this case, the subnet, whatever you're left over with, would be your answer. All right, what is the dotted decimal equivalent of a \30 subnet mask? So 255.255.255 and then .252. All right, but now don't get confused by the wildcard mask because that's also a dotted decimal. But just remember, if it's asking for the subnet mask, that's how many. When you look at that's how many bits you can't use because they're all covered. A wildcard mask is how many bits you still have left to use. Okay, I guess that might help out a little bit. All right, subtract the dotted decimal representation of \30 from 255.255.255.255. So that's making a wildcard mask. So figure that out yourselves. But so \30 is right here, what I just did. So that'd be all 255s, and the last one would be 252. Whatever's left over from that is right there. All right. So what that's telling us, we have 4, which is 3 plus 0. We have 4 possible or 4 usable addresses left. All right. So configure the routing process on router 1 with the network statements and wildcard masks that are required to activate OSPF routing for all the attached networks. The network statement values will be the network or subnet addresses of the configured networks. All right. So just be careful though, because see how it asks for the network. All right. So like network. All right. Portion. Network address. All right, wildcard mask, area, and area ID. Okay, so it's like a lot of stuff in there. So let's get to it here. All right, so it says configure router 1. Alright, so network address, we'll start with LAN 1. There's the network address right there, 2.168.10.0. Alright, enter a wildcard mask. So if the subnet mask is 255.255.255.0, we're going to flip those around. So 0.0.0.255, and the area is 0. And kind of like, it's kind of hard to see, but this is bold. So this is actually the command. This is actually the command. This is what it's looking for. You type in for your network address. You're typing out. Actually, you're typing out the wildcard mask there, and then you're typing the word area and then area ID, but just the number of the area ID. All right, just so network, the word network, the actual network, the wildcard mask, and then area, and then the area ID, which is 0. Oh, you know what? Area OSPF10 config. Okay. Now let's do it. .10.0 0.0.0.255 area 0. All right. So we're kind of like doing this out of order a little bit, but we had to go back into the config router global config menu. So type it in router OSPF10, and then I typed in the network. All right. So let's see. Verify that OSPF has been configured properly. All right, so we need to do, that's one of our networks. Now we need to do the next network. It really didn't tell us we have to redo that, I don't think, unless I didn't read it. Configure the routing process and run the routing network statements. Yep. So kind of like we probably should have done it right there. OSPF process ID, enter the router ID, and then enter all the networks that are connected to that device. All right, so our next network, I just go in order, 10.1.1.0. All right, so 30 is a 255.255.255.252. 255 minus 252 is 3. So 0.0.0.3. If you think about it, all right, we got 4 possible addresses. 3 plus 0 is 4. All right, area 0. All right, and then I'm going to do up arrow. Then our file network, I could use most of that, but 10.1.1.4. Same wildcard mask as 10.1.1.0, area 0. So I could have just done an up arrow for my history, changed out the 4, and I'd be good. All right, and apparently we're doing pretty good because we're at 33% completion. All right, so let's see what we got here. All right, so verify the OSPF has been configured properly by displaying the running config. If you find an error, delete the network statement using the no command and reconfigure it. And yes, you probably need that a whole bunch, but anything you typed in, like networks are typed in incorrectly, you can do the up arrow, go into your history, go back here. You can type in no and see how my completion rate went down because that was entered correctly. But if it wasn't entered correctly, and then you go back in there, and you would enter the correct command, enter that, and then it'll take out the old command and enter the new command. Now, if from config router, and I know in the when I was doing the little practice terminal connection or terminal interfaces they have in the chapter, I guess you would call them, to back out of this, if you type end, it takes you right out to the privileged exec. So then you can do show run. So now if you try to do end, then end, back out of it one line at a time, it errored out. So just understand that. And then I'm going to hit tab, my spacebar. All right, so this already had descriptions and IP addresses for the interfaces. We just had to enter the router OSPF stuff. So we entered router OSPF 10. We put an explicit router ID in there. We didn't put log GNC changes, but we did put these networks in there. And if after you enter those, I would probably verify them. You know, in real life, you're not going to have a completion rate changing, so you have to check to make sure your network's correct. So if we did, all right, looking up here, 192.168.10.0, that's right. The inverse of a 24, backslash 24 is 0.0.0.255. Area 0, because everybody's on area 0 in this area. All right, 10.1.1.0. Instead of a 255.255.255.252, we're doing the inverse of that, area 0, and then finally, all it changes is the last octet. All right, and that looks fine. All right, so we're good with that. Let's see, configure networks for OSPF routing using interface IP addresses and quad 0 masks. On router 2, configure OSPF using network commands with the IP addresses of the interfaces and quad 0 masks. The syntax of the network command is the same as was used above. All right. and that's router 2. So let's click router 2. All right. Now interfaces, we need to figure out the interfaces for router 2. So they're up here. All right, 3 interfaces right there. All right, so let's do, and again, see how it's easy to start off just with global config, but we actually have to go back into the router OSPF. And if I do, let's see, router OSPF by itself, I'll put the process ID in just to be sure. If I went without it, I don't think I'll take out that process ID, but I want to be sure. All right, so let's start with the gigabit. Network 192.168.20.1. All right, inverse, so 0.0.0.255. Area 0. Wait. Make sure I'm not doing this wrong because that didn't look right. All right, on router 2, configure OSPF using network commands with the IP addresses of the interfaces and the quad 0 masks. All right, so yeah, that didn't look right. All right, so what we're doing here, we're telling it use this specific IP address. All right. So instead of a \32, which is all 255s for all 4 octets, you're putting in the inverse of that. Right, so at that, and then area 0. All right, so that looks good. I'm going to do up arrow. Might help me out a little bit. All right, then we'll do our next. All right. And it's more confusing than it's worth. All right, so 10.1.1.2. And notice those definitely aren't network interfaces because they're odd numbers, right? That's definitely an odd number, so it's not a network interface anyways. All right, and 10.1.1.2 is even, but we're doing it's going to be a 255.255.255.252 because it's \30, so we do the opposite of that. So that'll be 0.0.0.3 because 255 minus 252 is 3. It would be best to look back at your little, this thing to see, make sure that wildcard mask is right. All right. Let's just close that down. And area 0 again. All right. And you can see it's already starting to exchange like hello messages and stuff like that. So it has the neighbor, howdy neighbor. All right, it's telling you hello messages. All right, so the last one we want to do, let's see, is the serial 011, which is, let's do up arrow. The only thing that's going to change on this one is the .9. All right. Still \30, so the inverse of the subnet is going to be that wildcard mask. Everything's area 0 in this case. All right, so man, we're at 50%. That's good. All right, so let's look back. All right, so the syntax of the network command is the same as was above. All right, so we're good. Step 3, configure OSPF routing on router interfaces. All right, so on router 3, configure the required interfaces with OSPF. Which interfaces on R3 should be configured with OSPF? All right. Obviously, in packet tracer, you can tell. All right. So it would be those three. 1, 2, 3. All right, so configure each interface using the command syntax shown below. So IP OSPF, and then the process ID, which is 10 in our case, the area, and 0. And notice right here, we're actually going into the interface on the global config. All right, so let's click there. So this is more steps, but this kind of like maybe makes more sense to some people. IP OSPF, process ID 10, or I'm sorry, see I'm about to mess it up. 2. All right, so let's do all right, so we're going to do the interfaces. So let's do interface gigabit 0, 0. And now let's do IP OSPF, process ID is 10, area 0. All right, so then that's it. All right, for that network or that interface. And then we'll go up to this one. And I believe we might be able to get an interface from here. So serial 0, 1, 0. Yep. So we didn't have to do the go exit. We just went straight into it. All right. So IP OSPF 10, 10 area 0. All right. So that one's done. Now we're starting to get neighbor messages from R2 is 2.2.2.2. So that's good. All right, so we've done 2, and finally we've got interface serial 0, 1, IP OSPF 10 area 0. So remember IP OSPF, and then it told us our up here. It told us our process ID, and then the area, it told us the error area. Those get mixed up a lot of times, but just remember process ID, they want you best practice to keep those the same, but you can change them if you want, but the area ID will put you in this area. So if you have multi-area OSPF, you have to specify the area. All right. OSPF area 0. All right, so that all should be good. Let's see. All right, so now we're on part 3, configure passive interfaces. OSPF will send its protocol traffic out to all interfaces that are participating in OSPF process. On links that are not configured to other networks, such as LANs, this unnecessary traffic consumes resources. The passive interface command will prevent the OSPF process from sending unnecessary routing traffic, protocol traffic out LAN interfaces. Which interfaces on R1, R2, and R3 are LAN interfaces? So, in this case, all the ones that have straight through cables that are black are LAN cables. Everything else is should be sending OSPF packets out. All right, so that'll be another question. Okay, configure OSPF process on each of the 3 routers with the passive interface command. So I'll go back to R1 first. All right. And it'll be all of our gigabit interfaces. All right. Oh, let's go to configure T, interface gigabit 0, 0, 0. All right. Oh, you know what? Let's do this. Let's do exit, because that's not going to work. Let's do router OSPF10. Let's do passive. Passive interface, internet gigabit 000. Interface, enter. Oh, typed it in wrong. Passive interface. Config router, passive, enter. What? Passive interface, router, config router. Yeah, I hit it right. All right, passive interface, gigabit. All right, there we go. I don't know what the heck I was doing. Gigabit interface, 000. Oh, duh. Alright, so, alright, I like that. Alright, cool. Been a while since I entered that. Alright, so the next one, let's go here. Router, config router. Alright, so that one's already up to that. So we can actually do this. Let's copy that. Whoops. Copy that. Export. What? Copy. It doesn't like me to do that. Interface locked. Alright, so let's go to R2. Alright, we're in config router already, so passive interface, gigabit. R2 is gigabit 00. Matter of fact, all of them are gigabit 00. So 0.0. Alright, that's good. And then finally, let's go to R3. And see, we're in the interface in that one, so we have to go to router OS. Let's exit out of it. Exit. OSPF10. Now we're in config router. Now let's do passive interface, gigabit 000. Alright, now we got it. Alright, now we're at 100%. Alright. It was kind of funny. I have up the, I checked the instructor manual and it's actually wrong. So it's funny, but this curriculum's new, so I understand. I make my curriculum myself, so I understand if there's a couple little errors. But the errors are, you guys don't see the errors, but I see them because I like to verify this. So the next time I do it, I don't have problems. All right, so use show commands to verify the network and passive interface configuration of the OSPF process on each router. All right, so let's do that. And I believe from here, if you want to do a shortcut, you can do show run. Yes. All right, so that just takes you directly to the running config from the global config. All right, so here we go down here, OSPF. All right, so there's our entries now. Router OSPF10, router ID 3.2.3. Passive interface is gigabit 000. All right, and see how it didn't do a bunch of. This looks a little different than the other ones because this doesn't show you a list of networks that have OSPF on them. This actually shows you the interface, each individual interface that has OSPF running on it. All right, so that looks a little different. All right, so for those three interfaces. Now let's look at R2. All right, so let's do a do show run from here. All right, notice how these interfaces don't have it like that. but router OSPF10, router IDs right there. Passive interface is the gigabit interface, and then your networks. All right. But notice now we specified this by putting in the equivalent of a /32 IP address of the interface. All right. So that might sound a little confusing, but notice how this is definitely not a network address because it's a odd number, but we're doing all zeros. So wildcard mask all zeros is the same thing as a subnet mask of all 255s. So that would mean use just that specific address. All right, and then for this one right here, we used a /30 for a router-to-router connection. So that's a .3 and then a .3 there for the .8 network. All right, so that looks a little different. And then finally, router 0. Let's do a do show run from there. All right. And now on this one actually has network addresses. These really stand out as network addresses because the last octet is 0, and then the third network is a .4. That's the same thing as a /30, /30, and then a /24. All right, so that's it. All right, and then obviously it's under router OSPF10. So that's really all we got to do here. We're good to go. All right. So really the only real thing that was a little way different was the passive interface. You had to type it in like in that syntax or it didn't work. All right, so you had to split up the gigabit Ethernet and then the actual interface number itself. All right, and that's it. All right. Well, thanks for watching, and I'll try to get my next video up shortly.